the first function that we're really going to focus on studying is absolute value functions. Y equals A times the absolute value of x minus h plus k. These are transformations. You guys studied transformations in Math 2, but you did it with geometry instead of algebra. You did it in terms of points being transformed and shapes being transformed instead of graphs. So you talked about like dilations, like a shape that got bigger or smaller. You talked about shapes being like rotated around the origin, or shapes being like reflected over the x-axis or y-axis, or even like y equals x or stuff like that. Does that sound familiar, those different like transformations and things happening to shapes or to points? You guys remember doing that? Okay, so this might be like vaguely familiar, but we're going to be doing transformations to graphs, and we're going to do it a lot. So it happens this unit, and then it happens for like the next 6 units. Like every unit, we're going to do the same thing. So you want to do your best to make sense of it and understand it, because the exact same types of questions will come up over and over and over and over again. So the first type of transformation is this A value. It's the number in front. And this is going to give you a stretch or a compression. In Math 2, you would have called this a dilation. So it gives you a stretch if the A value is bigger than 1. And I'm not talking about if the A is positive or negative. It doesn't matter what the sign is. I'm talking about the size of the A value. So it could be 2 or negative 2. It could be 1.5 or negative 1.5. It could be 4/3 or negative 4/3. So it doesn't matter if it's positive or negative. It just matters if the size of the number is bigger than 1, then it's going to take the graph and it's going to stretch it. So it gives it the appearance of looking tall and skinny. That's what it does. Compression is going to be if the A value is less than 1. So again, it doesn't matter what the sign is, it just matters what the size of the number is. So 0.5, 1/3, negative 1/2, negative 0.25. If the size of the number is less than 1, it's a compression, which looks like a squish. That's another word you might hear. So it looks like somebody took the graph and they squished it between their hands, which gives it the appearance of it looking short and fat. Okay, so stretch, tall and skinny, compression, short and fat. If the A value is negative, then the graph has been reflected over the x-axis. It means the graph is upside down. If the A value is negative, the graph will be upside down. All right, for the H value, H is going to shift the graph to the left and to the right. And it's always the opposite of what you would think. So a positive number shifts it to the left, a negative number shifts it to the right. The number on the end, the K value, shifts the graph up and down. And this is exactly what you would think. A positive number shifts the graph up, a negative number shifts the graph down. So we're going to go ahead and graph this on a calculator so you can see how to do it and see what it looks like. So to start with, I'm going to show you guys how to clear your calculators. So to clear them, we're going to hit second, which is the blue button, second. And then the plus sign, so second plus, and then 7, 1, 2. 7, 1, 2. Second plus 7, 1, 2. Second plus 7, 1, 2. All right. So now we're going to go ahead and graph an absolute value graph, and we're going to do that by hitting the y equals button right here. We're all going to go to the y equals button. Looks like this. And then we're going to graph what is called the parent function for an absolute value graph, and that's just y equals the absolute value of x. Y equals the absolute value of x. And does anyone remember what an absolute value symbol does to a number? It turns negatives to positives. And does anyone know what absolute value actually means? Yeah, it has a very special meaning, though. There's a reason why it forces numbers to be positive. And a lot of people, this is kind of a random fact, a lot of people don't know. So the reason it forces numbers to be positive is because the meaning of absolute value is it's the distance of that number to 0. And distances are always positive. So if you said, what's the distance from the number 5 to 0, you'd say, oh, it's a distance of 5. If you said, what's the distance of -3 to 0, oh, the distance is 3. So anytime you put a number inside an absolute value sign, you're basically saying how far away from 0 is that number, and that is why the answer is always positive, because it's talking about a distance. Okay, so absolute values, they make numbers positive, and the reason they do that is because they're talking about a distance. Okay, so to get the absolute value sign in our calculator, we have to hit the math button, which is underneath the green button. So hit the math button, and then we go over to number. So hit the math button, go over to number, and it is the first option. You're going to press enter on the first option. ABS is absolute value. So math, go over to number and press enter, and it will put the vertical lines in there for you, and then you just have to type the X, which is right next to the green button. All right, everyone got that so far? Okay, now all we have to do is hit the graph button. And it graphed it for us. It's a perfect V-shaped graph. It's right over here on the right side. Right? Now, above the graph button in blue, it says table. If we want to get the table of values, we just need to use the second button over here, the blue button, to get that. So we're going to hit the blue button and then the graph button to give us the table. So second graph will give us the table. And now I'm going to fill out the values. So if I plug in 0, I get 0. If I plug in 1, I get 1. If I plug in 2, I get 2. And this makes sense because if you plug in 0, you're saying how far away from 0 is 0? 0. How far away from 1? What's the distance from 1 to 0? It's a distance of 1. What's the distance from 2 to 0? It's 2. If I go back the other way in the table to look at the negatives, what's the distance from -1 to 0? It's a distance of 1. What's the distance from -2 to 0? It's a distance of 2. So anytime you plug in a negative, you're going to get a positive number. Anytime you plug in a positive number, you're going to get a positive number. So there's our table of values. Are we good so far? Yes? Okay. All right. So here we have a perfect V-shaped graph. I'm just going to draw a little sketch of it over here. Okay. And then right here in the middle of that V-shaped graph, we have a point that is called the vertex. And so on the parent graph, the vertex is at the point 0, 0. Now, if you have done any transformations, if you've moved the graph at all, then the vertex is going to be h, however far you shifted the graph left or right. It's going to be h, comma, k. K is however far you shifted the graph up and down. So the vertex for the parent graph is 0, 0 because we didn't shift the graph anywhere. But if you did shift the graph left or right, up or down, then that's what the new vertex would be. Okay, so let's look at a couple examples. So if we look at this graph, we have a 2 in front. This is the a value because it's the number in the front. Is 2 a negative number? No, so it's not going to be a graph that's upside down. Is 2 bigger than 1 or less than 1? Bigger than 1. Okay, so that means that this graph has been stretched. The V shape is going to be a little bit taller and skinnier than the normal graph. Okay, so this graph has been stretched. And we can put a V in front. It's been vertically stretched. That's probably something I should have put in the notes. So let's go back here. Vertically stretched or vertically compressed. If you go on to pre-calculus, so Math 4 or pre-calculus, you learn about horizontal stretches and compressions. But in here, we just learn about vertical. So it's been vertically stretched. Inside here, we have a -3. So if you look here, should it have moved left or should it have moved right? Right. So this graph moved to the right 3. Okay. And then it has a -1 on the end. Did it move up or down? Up or down? Down. It moved down 1. Okay. So the normal V, I'm just going to lightly sketch this. The normal V just goes like perfectly through the corners. And if you want to sketch it very lightly, feel free to do that. This is the parent graph. It just goes perfectly through the corners. And now we're going to see what ours looks like. So the vertex for our graph is going to be the opposite of this number, +3, and that's a -1, so -1 on the end. So with the first value to get the x coordinate, we do the opposite of that number. For this number on the end, we take exactly what it says. So +3 and -1, that's the vertex. And then we have all these different transformations. Okay, so what I'm going to do is I'm going to write down the points from the parent function, and we're going to do all of the transformations to the points. And you might remember doing something similar to this in Math 2. Did you guys ever do transformations to points in Math 2? Shifting them left and right, shifting them up and down? Okay, so that's what we're going to be doing next is we're going to take all these points and we're going to do the transformations on them so that we can see what the graph should look like, okay? So if you take the graph and you vertically stretch it, you make it tall and skinny, is that going to change the x coordinate of the point or is that going to change the y coordinate of the point if you are making it tall and skinny? It's going to change the y coordinate because the y coordinate has to do with up and down. So if you're making something taller, you're going to change the y coordinate. You're going to change the up and down coordinate. So to do a stretch of 2, we're going to take the y coordinate and do what with it if we want to make it twice as tall? Multiply it by 2. So I'm going to take my y coordinates and multiply them by 2. So I'm leaving my x coordinates the same. And then I'm not going to put a note by this y coordinate. So these are the parent graph. If you want to label anything, that's what you could label there, parent graph. And now here I'm going to do 4, 2, 0, 2, 4. So what I did is I took the y's and I multiplied y by 2. And that was for the stretch, the vertical stretch of 2. Okay, if I wanted to shift the graph to the right 3, would I do that to an x coordinate or would I do that to the y coordinate? X coordinate. Shift the graph right 3, I'm going to do that to an x coordinate. And should I take the x coordinate and multiply it by 3 or should I add 3? Add 3. If I multiply it by 3, I'm going to make it 3 times as big. I don't want to do that just to move it to the right. Okay? So to move it to the right, I'm going to add 3. Uh-huh.
So that 4.
Mm-hmm. So I took the 2, multiplied it by 2, and got 4. Oh, yeah, because the x coordinate. So here, -2 plus 3 is 1. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. Okay, and then I'll leave the y coordinates the same. Okay, and then our last transformation is to shift the graph down 1. If we shift the graph down 1, is that going to be the x coordinate or the y coordinate? The y coordinate. And how do we shift down 1? We're going to -1 from the y coordinate. Okay. So I'm going to take all my y coordinates and I'm going to subtract 1, subtract 1, subtract 1, subtract 1, subtract 1. And then when I graph my function, it's going to be the last column. So over 1, up 3. Over 2, up 1. Over 3, down 1. There's the vertex right there. Over 4, up 1. Over 5, up 3. Okay. That was a lot of information. How are we feeling? So you could graph this in a calculator, but I want you to understand where these graphs are because if you continue on in honors math and you don't stop at like a 4th level math, if you decide to continue on, you want to go to pre-calc, you want to go to calculus, there's a point where they start to take your calculator away and they expect these graphs to be in your head. So I want to give you guys the tools to be able to graph things in your head and not have you shut down when you see a graph and you don't know exactly what it looks like. I want you guys to be able to do it. So I'm trying to give you guys a good understanding of what things look like. Okay, so let's graph this in our calculator so we can double check those points. So I'm going to hit y equals. While it's hovering over this, I'm going to hit the clear button, which is right here. So I'm going to clear that out. So I've got the 2 in front. I'm going to type the 2 first. Now I need the absolute value sign. How do I get the absolute value sign? Anyone remember? Nope, I have to hit the math button. And then I go over to number. And then I press enter on absolute value. Okay? Inside the absolute value, I need x minus 3. And then I'm going to go outside of x minus 3. Press minus 1. We good? Okay. So hitting graph will let us just kind of visually look and say like, okay, that looks kind of similar. But if we want to compare the actual points, then Victor, this is what you were remembering. This is the second graph. That's how we go back and look at the table. So second graph lets us compare actual table values. And the table values I typically look for is I look for the vertex, and then I look for a couple values above that and below that. So the vertex was at 3, -1. So 3, -1. There's the middle, 3, -1. And then 2, 1, 1, 3, 3, -1, 4, 1, 5, 3. So now we've compared with the table. We got the points right. Okay? We good? All right. Let's move on to the next example. Okay. We have a negative in the front. What does the negative in the front mean? Not compression. You're right, there is a compression, but it's not because of the negative in the front. Reflect over the x-axis. Okay, and then how do we know there's a compression? Because you were right about that. Say that again? It's less than 1. So the 1/2, the size of the number in front is less than 1. 1/2 is less than 1, so this is a vertical compression. Okay? So reflect over the x-axis because of the negative, and then the size of the 1/2 is less than 1. That's a compression. We have a +1 inside. What does the +1 inside mean? Left. Left 1. Okay? And there is no number on the end. I'm going to go ahead and put a +0 because that's going to help me figure out what my vertex is. Okay. So for my vertex, it has to do with this number and this number. So for the vertex, we do the opposite of this number. What do we get? -1. And then we take this number exactly. So the vertex is -1, 0. Are we comfortable with that? -1, 0. Okay. All right. Now, the important points that I want to look for, I always start with -2, 2. These are from the parent graph. -1, 1. 0, 0. 1, 1. 2, 2. Those are the important points I always start with.
So every single time we start with
Mm-hmm. And this, we're always going to start with this anytime we're doing an absolute value graph. Now, if I was doing a cubic graph, x to the third, then I would use the points from the parent graph of an x to the third. So we'll get there when we get to cubic graphs. If I was doing a quadratic x squared, then I would use points from an x squared graph. So we use these points because these points came from the V graph. They came from the absolute value.
So when there's like
Mm-hmm. Yep. Yep. Yeah, you always want to have a number on the end so that you have a y coordinate for your vertex. Yep. Good question. Okay, so we've got those points. To reflect over the x-axis and do the vertical compression, you can do that transformation at the same time. Okay, so we're going to picture what's happening. We have the graph, the v goes up, and if you flip it so the v is going down, sorry, I can't, hold on, let me show you. We're going to start with the v. The v is starting up like this. That's a v shaping up, right? And you flip it so the v is going down like this. Is that an x movement, a left-right movement, or is that a y movement, an up-down movement? Okay, so that's going to impact the y coordinate, all right? Then we also have a vertical compression. We're taking the graph that's this tall, we are squishing it so it is half as tall. Is that an x coordinate change or a y coordinate change? That's a y coordinate change. So since these are both y coordinate changes, we're going to do them both at the same time to the y coordinate. We're going to change the sign of the y coordinate, and we're going to make it half of the value that it used to be. We're going to change the sign, and we're going to make it half of the value that it used to be. So we're going to take each of the y coordinates, and we're going to multiply them by -1/2. Take each of the y coordinates, and we're going to multiply them by -1/2. Does that make sense? Okay. So 2 times -1/2 is what? -1. 1 times -1/2 is -1/2. 0 times -1/2, 0. Okay, and then we just have 1 times -1/2 again, and 2 times -1/2 again. Okay. So we only did one procedure. We just multiplied y by -1/2, but that took care of two transformations at the same time. It did the reflect over x, and it did the compression. Okay? Now we want to shift left 1. Does that impact the x-coordinate, or does it impact the y-coordinate? The x-coordinate. And how do we move left 1? U minus. So we're going to take the x-coordinates, and we're going to minus 1 from the x value. Okay, so I'm keeping the y coordinates the same. So now I have -3, -1, -2, -1/2, -1, 0, 0, -1/2, 1, -1. Okay, are we good with that? Okay, so I'm going to take my calculator. I'm going to press the y equals button. While it's hovering right here, I'm going to clear that equation. So the clear button is right here underneath the down arrow. You can type in -1/2 in the front a couple different ways. So the negative is down here. I typically just type it using division. I would type -1 divided by 2. That's what I would usually do. So -1 divided by 2. I think it's just the easiest way to type it. So -1/2. How do we get the absolute value in there? Math. Go over to number. And press enter because ABS is what we want. Okay? And then inside the absolute value, we want to type x plus 1. And we're going to hit the graph button. We can see that graph is definitely compressed. You can see it looks a lot wider than the other graphs have. And now if we want to see the table and just make sure that our table values are on there, we can press second graph. And I'm just going to look for my vertex, -1, 0. I look for my vertex, and I can see a couple points above that, -3, -1, -2, -0.5. There's my vertex, 0, -0.5, and 1, -1. I can see that my points are right. Okay. All right, let's try the last one. So this one, I made it an inequality, so that means we're going to have to figure out if we have a dotted line or a solid line, and we're going to have to figure out where the shading should be, okay? So before we do that, let's go ahead and figure out what our transformations are. I'm going to have us write this an alternative way because the way that it's written is a little bit confusing. So we've got 4, and then in the absolute value sign, I'm going to put x plus 0. And then a -5. So since the x was all alone in the absolute value, it's a little bit nice to have a number in there as well so that we can think of it still in the correct way to be able to find the vertex. So if there's not a number inside, it can be a little bit confusing. It's nice to have that number in there to be able to work with that. Okay, so there's a 4 in the front. What does that 4 mean? Stretch. So vertical stretch of 4. This graph is going to be very skinny, really skinny graph. There's a 0 inside. So what is this graph not doing? What movement are we not seeing? No left, no right. It's going to stay right in the middle. And then it has a -5 on the end. What is that? Down 5. Okay. So the vertex of this graph is 0, -5. The vertex of the graph is 0, -5. Right here at the very bottom. Okay. And then I'm actually not going to have us find the points for this one. I'm just going to have us graph it on a calculator. So we're going to go to the y equals. We're going to press clear. And we're not going to have the calculator do the inequality for us, but we are going to have the calculator help us find the points. So I'm going to type the 4. How do I get the absolute value? Math. Go over to number and press enter. Okay. 4 times x minus 5. So that's what we're graphing. Okay, it looks like that. And then how do we get to where we can see the points? Second graph. And we're looking on the table for the point 0, -5. We want to find that because that's the vertex. That's the very middle of the graph. And so to graph it from here, we're going to say this is the middle. So I'm going to do 2 points above that and 2 points below that on the table. And then that will be enough points for my graph. So I've got 0, -5, -1, -1, -2, +3, 1, -1, +2, +3. Okay, so there's my graph. There's my table. And based on the symbol, should I have dotted lines or solid? Dotted. So we can see this symbol right here. It does not have an equal sign, which means this should be dotted lines for the V. Now, in a straight line graph, we would normally shade maybe like above or below the line, or to the left of the line, or to the right of the line, because you only have like two sides of a straight line graph. With a V-shaped graph, you either have the inside of the V or you have the outside of the V. So you still have two sides, it's just the two sides are defined a little bit differently. So we're going to have to figure out if the point makes it true or false on the inside of the V, and then if the point makes it true or false on the outside of the V. So we could still use 0, 0 to plug in if we wanted, or we could use another point. What would you guys like to plug in? 0, 0? Okay, so 0, 0 is right here. 0, 0 is inside of the V, okay? So we'll go ahead and plug in 0, 0. We've got 0 for x and 0 for y. So 0 is greater than 4 multiplied by the absolute value of 0 minus 5. The absolute value of 0 is just 0. So we have 4 as being multiplied by 0. What is 4 times 0? 0. And what is 0 take away 5? -5. All right, is it true that 0 is bigger than a negative? Yes, this is true. Okay, so the inside of the V is true. That means the outside of the V is false. And so where should we shade? The inside of the V. Okay,